Thank you very much, and good afternoon, everyone. So, I'm Andy Clark. I'm the chair of Hydrogen Southwest and a board member of the British Aviation Group. As discussed, whilst UK governments are focused on the SAF and decarbonising aviation through SAF, a lot of airlines and organisations are laser focused on hydrogen as a long-term sustainable solution for the industry. So today we're going to talk about some of the primary applications for that and the projected timelines for how we can roll hydrogen out. But first, why hydrogen? So hydrogen has been safely and effectively used actually for many years in the space industry and automotive industries. But today's challenge is how do we move that to a commercial aviation? Hydrogen's extremely high energy to mass ratio makes it very appealing to aerospace applications. As Dominic Weeks mentioned in the previous panel from Zero Avia, very, very good fuel for decarbonising aviation. But the main hurdle is its ambient density. So if it's cryogenic, it needs to be stored at minus 253 degrees. And if it's gaseous, it then needs to be in a pressurised container. So some of the technologies in terms of storage are quite a challenge. So hydrogen, when we're talking about it in today's panel, can be burnt in a jet engine through its traditional combustion, or used to power a fuel cell, which then powers the electric propulsion. So today we've got aerospace experts who are working on accelerating the technologies to supporting this fueling infrastructure. So I'm just going to, with this esteemed panel, go down the line and talk about, let them introduce themselves. We do have Slido, so please, if you have any questions, I do have a magic iPad here that can, so I'll get your questions and I'll raise those after I've done the introductions. So, Hervé.
Hi, well, good afternoon, everybody. My name is Hervé Morvan. I'm the Rolls-Royce Chief of Future Platforms. It means that I run a small internal think tank, if you want, or advanced concept team in Rolls-Royce interested in anything that is beyond business as usual.
Brilliant. Welcome.
Thank you.
Yolanda.
Hi, good afternoon. Nice seeing you all here. I'm Yolanda Stevens. I'm working for KLM. I'm working in the program of zero emission aviation. And this program is aimed at building the strategy forwards with the new technologies for decarbonization. So we're thinking battery electric and of course hydrogen. And not only building this strategy or thinking it out, but actually implementing it. So really engaging with the ecosystem in order to get things off the ground.
Brilliant. Welcome. Greg?
Hello, Greg Easter. I work in the UK's Department of Transport. So DFT's role is coordinating government's strategy on decarbonisation of the UK aviation sector. We also represent the UK in negotiations in ICAO as part of the UN internationally. So my specific focus is around zero emission flight and what these sort of novel forms of propulsion can offer within that basket of measures that we're going to need for aviation and net zero. So it's partly kind of what can hydrogen and zero emission flight do for aviation to decarbonise, but also therefore what are the implications going to be for the sector and for passengers.
Brilliant. And Helen?
Hi, good afternoon everyone. I'm Helen Ledbetter. I'm the UK Civil Aviation Authority's Technical Strategy Lead for Zero Emission Flight. I'm currently leading our work, what we call the Hydrogen Challenge, looking at different propulsion systems and different technologies that are being presented to us by industry and looking at a certification and regulatory pathway to enabling the safe introduction of hydrogen as an aviation fuel.
Brilliant. Well, welcome. And so it was mentioned earlier as an introduction around Airbus and their I know they're fully committed, and we heard about Tim earlier, fully committed to delivering and developing an aircraft on hydrogen, but they have pushed back their timescales. And so what are the key applications for delivering a hydrogen in commercial aviation, and what's the sort of realistic timeframes do we think we're going to talk about? So who should we start with? Let's start with the engine maker.
Yeah, okay, thank you. I think perhaps a mistake that was made was indeed to conflate net zero 2050 with hydrogen as the solution for it. I think some push really hard for that, and if you did the sums, it was obvious that that was never going to be the case. If you take, for example, narrow bodies and maybe responsible for 30% of your aviation emissions, if you have a fleet replacement over a 25-year, let's say 30 period, to be simplistic, and you have an EIS in 2040, you are going to hit 10% reduction of the emission, assuming everybody replaced their assets with that. So, and that's a bit of a setback, because long-term, cryogenic fuels, but also other technologies like batteries, offer quite an attractive prospect economically, etc. And so we need to make sure that right now we've got the right focus to hit net zero 2050, but we don't lose sight of the necessary curiosity, amongst which hydrogen, to basically be ready to scale in the longer term. I think that's an important, perhaps, lesson. We fired one cartridge and missed the target. Maybe we just need to make sure that we set realistic targets, achievable targets, perhaps for the longer term, and retain that curiosity that is necessary to drive such technologies.
Do I dare ask then, what sort of realistic targets are Rolls-Royce working to?
Well, I think for us we are working to meet basically interest of airframers. It's clear that the only solution that scales is a gas turbine into segments like narrow body or long range, which collectively are accountable for 95% of the emissions. So that scalability is key. But at the moment there is no airframer driving basically a demand for a combustion fuel system or a gas turbine. So we've done due diligence, we've run our first engine on 100%, modern aero engine, because that has happened before, on 100% hydrogen in 2022. We've had, supported by the ATI and Clean Aviation, a number of successful technology programs around the fuel system and around the engine. But at the moment, there is no airframer pool to basically take this on. So for us, we stand ready at a number of technologies. Are TRL 5 to 6 ready right now in terms of the combustion in particular. No particular challenge, including around things like NOx, which were initially thought to be particularly difficult to address. But now we need to figure out where the airframers are at. I think Boeing have expressed a view that for them it was in the beyond 2050, 2060, in a column that was written in 2023. Might have changed since then. And as for Airbus, they are focused on fuel cells for the time being.
Okay, thank you. What about from an airline perspective?
Well, it's very good to hear, of course, what the developments in the market are, also with regard to the engine manufacturers, because the main issue we have as an airline, of course, is that we are totally dependent on technology developments by not only the airframers but also the engine builders. But nonetheless, we believe that there's a lot happening in the market. So for one thing, we have the legacy OEMs and the things that Hervé just describes, and we are looking at that with great interest and also trying to influence where we can. But that's, the amount of influence we have is, of course, very limited. On the other hand, we see a new emerging segment of startups trying to disrupt this existing market of OEMs, which is a very blunt and very courageous thing to do. And as an airline, we believe we really have to help this segment of new OEMs in trying to get this to market. So, for instance, a firm like ZeroAvia, who is willing to pioneer in this segment by retrofitting an existing aircraft, we are extremely interested in this movement because I think it might disrupt the market as it is. The new OEMs disrupting the existing OEMs. There's a different sense of urgency. There's no order book for this new segment of upcoming OEMs, and this is a very interesting thing. So, as an airline, although we are not an engine builder or we are not an airframe builder, I think by stepping in and by collaborating with the new parties and really driving industry change, we can help develop and speed up the process.
Brilliant, thanks. Greg, what about from the government's perspective?
So certainly agree with the sentiments around we are not focusing 2050 purely around hydrogen. Our strategy for net zero has always had a basket of measures. There's a lot of work going on, as has been discussed earlier, on sustainable aviation fuels, airspace modernisation. So from a government perspective, there's no sort of question of having a single focus. I think also some of those other measures in that basket of measures also have dependencies on hydrogen. Obviously SAF is going to need hydrogen. It's going to be a very important feedstock, particularly as we move into sort of synthetic fuels, power to liquids. So there's some opportunities to sort of align work with that. And also things like sort of carbon capture and storage also sort of brings hydrogen into the sector. So to sort of answer your question more directly, we see the same as just been discussed. There's some innovators, disruptors trying to certify aircraft this decade, but in terms of sort of larger commercial market, looks more likely to be the 2030s out to 2050. We expect it's going to start initially on shorter haul, sort of European type routes. So there may be a situation in a couple of decades where we've got an emerging hydrogen aviation sector, lots of flights, but the actual carbon abatement may be relatively small compared to other measures, whilst that draws up. But in terms of sort of what does commercial mean, there's already hydrogen being used at airports in airside environments. Certainly I know Heathrow have an airside, landside, refuel it already. I think Teesside Airport, I can see in the corner of my eye, already have some hydrogen facilities. So we're not starting from scratch. There's already stuff out there being used on airports.
Good, thanks, Greg. And Helen, finally, from a regulator point of view.
So through the Hydrogen Challenge, we're seeing quite a variety of technologies coming forward to use hydrogen. So the fuel cell system seems to be the most advanced, and that's what we're seeing would probably be the earliest entry into service. So with the likes of Zero Avia, they've already done their test flight under our permit to fly requirements here in the UK. We're looking at, within the Hydrogen Challenge, we've got other fuel cell technology industry members working on that. We've got combustion components. We've got applications in the RPAS and UAS sector, and for high altitude platforms. So we're looking at many different areas where hydrogen could be used in aviation. Yes, they're not all of them are going to be making the big impact straight away on the emissions that are created by much larger scale aircraft, but you're seeing this technology on, shall we say, smaller applications enables industry to build the confidence in that, and it also helps us look at what that regulatory pathway needs to look like. So we're seeing a range of dates from 2027 onwards, depending on the size of application and the type of propulsion system that they're looking at being used. And also they're asking a lot around what is needed for them to comply within the current regulations, and understanding the gaps that are there and how they can use special conditions and acceptable means of compliance to enable the certification process with regulators to be smooth, and also how they can bring forward the correct safety measures and prove that their applications are safe. So this is why we've set up things like the Hydrogen Challenge with the support of DFT to enable those safety challenges to be recognised and how they can be worked on within a safe environment.
Brilliant, thank you. That actually is a really good question coming from the audience, so which I'll build on off that. So, in terms of the UK, the UK is the third largest aviation industry in the world, and then actually, and we talked about it in the last session. Actually, the last new aircraft that was actually had to go through a lot of regulatory and approvals was Concorde. So, again, developed here and across Europe. So, in terms of lots of innovation and R&D in the UK. And so the question is, when can we expect to see a UK-funded national hydrogen aviation programme that brings together the good work of the CAA, industry and government?
Well, there's lots of existing programmes. Stuff certainly going on in the aerospace sector. Helen's already mentioned the Hydrogen Challenge, the CAA running. So there's lots of work going on. I think your question is sort of
bring it together into
listening.
one. I think it's more of a, there's lots of little programs going on. How do we bring that together? Going back to Johannes' thing around collaborative, it's all about having work together and support. How do we bring all that good stuff that we're doing across the UK into one knowledge pool, so we can go faster?
I was going to say. I think for me, it's what do you need to succeed? And I'm not sure that going to fly tomorrow is necessarily success, because you need to have sight of your market. However, we know what the pinch points are. The pinch point is the fuel system in general. That's a skill that the UK has. Rolls-Royce fuel systems in the UK. I think Airbus's fuel system is dominantly in the UK. And I think that understanding what are the cornerstone elements of that and making sure they are shored up is key, because they who can basically move the fuel about the aircraft will be kings of the hill here. Burning hydrogen into a GT is comparatively slightly easier. When you've got the two, you've got the product. The other thing to consider is that perhaps compared to other nations in Europe, the UK is not as strong or as well equipped when it comes to cryogenics capability, cryogenics know-how. If I think about some of our competitors in France, because of the space industry, they have access to far greater facilities and know-how. There is a pool that exists here. In the UK, it is slightly more difficult. And this gap also means that the supply chain is not necessarily as robust or as pre-existent as would be. So for me, one of the things I think I would advocate is that focus on what does it take for your nation to win and be ready on time, what needs to be shored up and developed. And I think that if we look carefully in terms of a balancing act between making sure we can meet 2050 and invest in that, but also maintain those curiosity streaks and those areas of competencies, develop them to be ready for the beyond, then I think that's where I would shore things up. And again, if you capture that at the right time, or you reinforce something you already have, fuel system competency in the UK, for example, then you're good. The converse of that is that a radical change of energy vector could also be the opportunity for some of those competencies to start somewhere else. And I think that's another way of looking at things. All the work done by the CAA or around airports is great in terms of learning, but we need to make sure we crawl and walk before we run towards something, because the initial cost of doing a fuel system is a few £1 million. Building a demonstrator is in tens of millions. Building a flying machine is a lot more money, and making sure we have a certain route to that build-up with a market in sight, with the right capabilities and competency, would be where I would focus.
I think to build on that as well, though, I think in some contexts it already exists, maybe not under one umbrella name, but as part of our funding requirements is to ensure that whatever we learn is shared with other regulators, with other forms of transport. We have our working groups that are set up. We have representatives from industry, from DFT, from EASA, from FAA, so we're looking at that much bigger international picture as well. So I think, although, like I said, it's not under one maybe project name, collaboration already exists. There's a lot of sharing of information that's already out there. It might not just be as obvious for those that are not being currently involved in it. So I always say if it's something industry or anyone else wants to be involved in, get in contact with whether it's the regulator or the airlines or the industry members, and start sharing that information, because it does exist. And we've seen it through Hydrogen Southwest and what you're doing down in that area, looking at how that supports industry. You've got a group of industry members that are together. So there's lots going on and we all talk to one another.
Excellent. No, thanks, Helen. And so for everyone in the audience, then get in touch with yourself or one of the airlines and get involved, or through organisations such as Hydrogen Southwest or British Aviation Group. Excellent. And actually, so building on that and collaboration, great for the UK, but actually aviation's a global market. So what sort of knowledge share is going on with other regulators across the world? Because it's all right having a hydrogen aircraft, you develop it in the UK, for instance, but where's it fly to? We've got to have the infrastructure needed at the other end and all the relevant certificates to fly into the airspace. So what's happening in various companies here to share that?
I would say for the Civil Aviation Authority, we have a really good working relationship with EASA and the FAA. Also with Transport Canada and ANAC, so that's the Brazilian National Aviation Authority. We're part of a regulators working group specifically for hydrogen technologies, and we're there to learn and share with one another to make sure there is alignment where we can, depending on each country's legal systems, to enable international aviation to continue with the use of hydrogen. So this has already been started. It's been going on for a number of years. I would say it's built a lot of momentum over the past 12 months. There'll be some inputs coming out some deliverables coming from those groups in the next few months, especially around gap analysis and understanding where the gaps are in regulation. And I think as working on it as a whole, you've got a breadth of knowledge and understanding of hydrogen technologies that can be brought forward and shared so that we have a much wider knowledge bank. And there's also test and demonstration activities that are going on in Europe that we can learn from. There are ones that are obviously taking place here in the UK. So there are lots of things going on. And with the FAA, we can draw on their experience with their test and demonstration centre they have in Atlantic City. They're looking at things like fire and rescue and how to look at the safety aspects. So yeah, there's a lot going on.
I was going to add to that, in clean aviation, which is a European large aerospace demonstration sort of fund, if you're not familiar with it. All the hydrogen projects had to engage the EASA in their projects, so we've run a number of activities and we have EASA as a direct partner involved. And as for us, some of our next testing will take place in the US in collaboration with NASA and then therefore, local authorities, the best of they have there is also involved. So a lot of these cross collaborations, as has been alluded to, is taking place. And beyond that, there's also been a number of projects. I'm mindful of Project Napkin here, for those of you who came across it, or a project like LH2GT funded by the ATI, where we've got collaborations with EasyJet as an airline, London Heathrow as an airport, and we are working together to sort of figure out, right, okay, how does that thing work practically? How does that work economically? And those, are the right thing to do because they are relatively small bets to place very early on compared to actually running a demonstration. So it's not necessarily complete. I think a lot is already happening in cross collaboration within the industry and beyond, but also internationally. And there was quite a strong mandate again back in Europe to have EASA involved in from the first moment we run those just after COVID, effectively.
Okay. And from an airline perspective?
Yeah, I agree on what Hervé says about building small collaborations with actual proof points. Because if you're actually entering into a situation where you're doing something together, and then with all the players in the value chain, setting up a whole value chain exercise or a demonstration flight, or that will really tell you what do we need to progress on further, which part of it's not working, what do we don't know. So the unknowns have to surface by doing actually the things together in the value chain. And I think it's really the international game here that's going to be key. Because if we're going to look at a national level, I think the Concorde showed us that a lot of competition has led to a lot of burning of money, right? Because there were in parallel many initiatives that burned to the ground, literally sometimes. And I hope that we can be wiser than that. We can do the same as in aviation, we regard safety as something that we don't compete on. We are open to that. In IATA, we are sharing the lessons learned. And this has led to aviation being a crucial, the most safe industry in the world. We should do the same. We shouldn't compete, but we should collaborate, also in the things that we are learning and that we are trying to achieve. Yeah.
Greg?
And I think it's just quickly worth adding, standards don't emerge out of ICAO. In isolation, they rely on people doing things in individual national programs to sort of test and demonstrate things, developing national standards that can then be sort of combined and sort of best practice can be thrashed out. I think with any new technology, there is always some group of first movers who are going to sort of set those first standards, which can then be convened upon to become global.
Excellent. Okay, questions here has come in around, due to the infancy of hydrogen technology in aviation, which we've discussed, it's hard to draw up regulations. So how does the CAA ensure that the lessons learned in the industry are then ensured to take the lessons that are learned in the industry?
No, absolutely. So what we do is we have our working groups that are set out. They're there to help us create policy recommendations. Within our 5-stage process for creating new policy and regulation, we have to go out to public consultation. So our first stage is always understanding what the driver is. So for us, we've had industry come to us and say we want to fly using hydrogen as an aviation fuel, whether it's as a gaseous hydrogen or as a liquid hydrogen. We then go and look at all of the requirements for that. So part of it has been doing gap analysis, and we do this with industry. We've done some initial work on this, and it's gone out to industry for peer review. So we look at what we can learn from industry and how they're looking to fill those gaps, and is there anything that they've identified that we haven't. We also look then to create that policy recommendation and send it into our SME teams, who will then write the first draft of what that regulation could look like. And then that goes out to the public consultation. And you'll see that's been done recently with our eVTOL program. They've put a lot of work out there on things like airworthiness, which is new. So we have a process that we follow. It's been used for a number of years, and we found that it's very effective. We take into account all the comments that come back in, and then we go through them and see which are applicable and which we don't think are applicable at the time, and then we build that into the policy recommendations. So that's the kind of process that we have in place currently.
Brilliant, thank you very much. Okay, another sort of question here is around, so if we potentially use hydrogen for SAF and direct hydrogen in aviation is in its infancy, why not just focus on putting it into SAF and in its first place?
Well,
probably one for the.
One of the things I was going to say is that so again, we might have had a setback by perhaps as a collective or some of us over-promising, but it doesn't mean that the technology is not potentially good longer term. Now, if we park this, anybody doing any sort of long-term projection of various aerospace scenarios will find that they have a lot in common. So I've worked on 50-year projections of where we could be, and you're going to say, how do you know that? Well, I don't, but there are scenarios. If you work backwards, what you find is that you in fact have a lot of commonality around certain needs for low-cost, low-carbon electricity, hydrogen as a feedstock. And these are no-brainer things that you could start now. Things are not siloed, and part of my concern about the hydrogen setback is people start to think hydrogen bad in a corner, and we're going to get SAF, and they would be missing the point that they have a lot in common. So if you look in terms of your 2050 energy mixes, which will be dominated by SAF, let's say 2/3 SAF if we meet some of the mandates, and 1/3 sort of normal kerosene. But if you then imagine a different future where hydrogen were beyond the 2050s becoming more dominant, what you find is that your ballpark electrification needs and investment and your ballpark hydrogen needs are not very different. So I think there is an important message here perhaps to address, which is there are things we can rally behind now, irrespective of what long-term future we believe in order to basically get the wheels in motion. If I looked at the summary that the CCC presented, I think yesterday morning on the main stage, you can quite see that they have an orderly procedure where they are decarbonizing main power, then looking at surface transport, then and household, then looking at agriculture, and then you've got others coming. Well, you need to be ready when your turn comes effectively, and part of this will require common levels of low cost, low carbon electricity, perhaps around, 20 exajoule the world over for 2050 aviation, and you'll probably need, 85 megaton of hydrogen. Airbus are talking about 100, and these are targets which we could rally behind, and when you've got that, you can then deploy those assets to follow what is the best route for you. We can already rally behind this today because they will shore up a SAF future, or they will prepare the ground for a long-term hydrogen one.
Yeah, thank you. And to add to that, it's interesting when I was talking to Airbus and others in the aviation industry that SAF is really good as an interim fuel because it's 70% less carbon than Jet 1 aviation kerosene, but actually it's still 30% of carbon emissions, and then if you look at the projections, the latest data came out yesterday that aviation is set to double in the next 20 years. So there's a lot more of us going to be flying, and a lot more people wanting freight. So it's we need to do something long term, not just in the short term.
But we can make decisions now that protect us against those different futures. We shouldn't say hydrogen bad. No, there are certain commonalities which we need to articulate clearly and get behind.
So another question on terms of investment. So a lot of people in the audience here will be looking at how can they help and invest in new technologies, etc. And we've heard on previous panels that there's a lot of companies out there wanting to invest. So from each of your perspectives, so what is it? What are the barriers to investment in your? Is it a government, or is it a technology, or is it a regulation, or is it just was it something else? So let's start with Helen. What's the barriers for the CAA?
For us, I would say it's understanding from industry when they want to enter into service with their technology. So what technology readiness levels are you at currently, and then when do we need to align our policy requirements to be enabled that we're ready and that we have proportionate regulation that's ready for use, for us not to be the blocker for industry enabling having hydrogen as part of their application for entry into service. And one of the other areas for us is always around funding. So we're a very small team that look specifically at hydrogen. So we're currently funded by DFT, but moving forward, it's like looking at how does industry then contribute to paying that within the framework that we have set up within our scheme of charges. So for us, it's all about when do we need to bring in relevant regulation, and then how do we ensure that we have the revenue and the capacity to enable that.
Okay. Greg?
So on investment, I think there are some quite well-known challenges around the attractiveness of people investing in technology. It's complex. It takes decades to bring to market. It takes very expensive R&D for decades to bring new aircraft to market. So a lot of that is well known. But I think by demonstrating, and I know some reference a few minutes ago to sort of SAP in an interim solution. It's certainly an interim that will sort of last all of our lifetimes, perhaps beyond. Given we've got aircraft that will use SAF rolling off the production line today. So I think the best way we can provide certainty for investors, is showing that aviation is a sector that's continuing to be successful. It's continuing to grow. Some exciting plans in the UK that we're expecting to see brought forward by Heathrow in the summer. So I think sort of government's main role at the moment is just sort of setting out that certainty that this is a sector that over the long term is going to continue to grow, and therefore sort of offer that attractive environment for investors.
Thanks, Greg.
I can echo part of that because unfortunately we are not a UK company, because or else I would be very happy with Greg's comments here. We are a Dutch company, and we have a Dutch government, and the predictability of our policies is a big uncertainty for us at the moment. So if you want to grow as an airline, or if you want to invest in a cleaner future, then you need to know, of course, what you're facing. And if we're able to grow, are we not able to grow, that's both things are fine, but as long as we know what it's going to be. We don't know what it's going to be at the moment, so investment-wise for a company like KLM, this is not very positive. If I look at the whole ecosystem, then of course it's very apparent that we need investment in infrastructure. We need investment in green energy. So renewable energy is at the basis of everything that we're trying to achieve. And if it's not there or if it's not scaled, then we will have grey hydrogen or we will have grid energy that is not green. So there are multiple ways in which investors can board this solution, and it will be parallel solutions. So I think you cannot go wrong, but also they need certainty.
Yeah.
When it comes to hydrogen, for us, we've pushed things probably as far as we could. We now need to see a demand pool, which there isn't in terms of the solutions that are available in gas turbines. So that's probably where we are at now. But back to your point about the doubling of the aviation market, that's a massive opportunity as well, a big economic opportunity. So rallying behind this is really, really important. Because if I look back at some of our plans to re-enter narrow body, for example, or to deliver ultrafan at long range, these things with their level of efficiency will play a key role in mitigating the impact whilst basically ensuring commercial success. If we don't take that opportunity, the market will still have a demand and will source its products somewhere else. So identifying basically those who can deliver this opportunity whilst helping addressing mitigation at scale is really key. And the last thing for me, at the risk of repeating myself, is indeed investment in low-cost, low-carbon electricity. We've heard in other presentations today, the situation of the UK grid, for example. That is really, really important. And still also making sure that we've got suitable environment for feedstock and biomass to become available to us.
Okay. Actually, we've got about 5 minutes left. So just based on green energy you just mentioned there, so is there any sort of demand study in terms of this is the amount of hydrogen that we are going to need as an industry that we can then send to the energy producers and generators? And so what sort of quantums are we talking about?
Yeah, I cited them earlier. Airbus said 100 megatons by 2050 for the whole of their ecosystem. My own sums were...
That's globally?
Global. My own sums were 85. I could give it to you for the UK. The same for the grid. These are wildly available and they converge. The interesting thing about those numbers is they, at least mine, they take into account a range of options, and it is electricity and feedstock that could go behind basically a SAF future or a long-term hydrogen future with a waypoint 2050 driven by SAF. So this is fairly available, and numbers have been cut. And you could go back to national studies, Project Napkin, which we were part of with ISRO and others, delivered some of those numbers for the UK, for a UK domestic market, for example, back in 2022.
Okay. And one final question that's just come in, actually. So what aircraft technology development is also win-win for both SAF and hydrogen, and how do we accelerate it?
So GT, doing a high-efficiency gas turbine, this works irrespective of what your fuel is, because a gas turbine will burn pretty much anything very well. So again, if you can deliver technologies which can run hotter with higher efficiency, irrespective of your fuel, that's basically a major impact. It's not only a reduction in terms of your emission, it's also a reduction in terms of your electricity need, feedstock need, biomass needs. So, you would say I would have said that answer, but I guarantee you that's the biggest impact you can get in one technology investment.
Brilliant.
There are some companies working on dual fuel engines, so then you would be independent of the infrastructure on the ground, able to operate an aircraft. I think that's also a very promising technology.
That probably helps your operation as well.
It would, but it's very far behind. So I think if we're looking at the time frame of development, this is one of the furthest on the time frame. It's interesting, of course. Yeah, we are interested. Yeah.
Great.
Anything that sort of takes weight out of an aircraft is the best way of saving carbon. Obviously, the best fuel is that which never goes on an aircraft. So anything, sort of composite materials, etc., which can drive efficiency is going to have benefits to both.
Helen, from a regulatory point of view?
A regulator, we're technology agnostic, so we're very much driven by industry. So whatever industry presents to us and looking to certify, whether it's sustainable or not at the moment, we will look to certify and work with them to achieve that. So.
Brilliant. Thank you very much. Well, I think it's been a great conversation on hydrogen and the future of aviation. I think there's a long-term growth plans for aviation, long-term future in various different fuels, SAF and then hydrogen. And it sounds to me like we've actually got some technology, and the UK can be at the core of this new energy transition. So can you all please, as normal, give thanks to our panel here. So thanks to.
Thank you.